Very good morning everyone. Welcome to my YouTube channel. This is Muralidhar. In this video, we are going to learn about gradient of the scalar point function. This topic comes under the module vector calculus. This is one of the very important concepts in engineering mathematics. The topic name is gradient. See, the formula is given by dou phi by dou x I cap plus dou phi by dou y into j cap plus dou phi by dou z into k cap. This is what the formula for gradient of the given scalar point function. So how we work? It is very simple. Let us consider a three-dimensional graph. See, I name it as x-axis and this is y-axis and as well as this is z-axis. This is what the initial axis, that is O. Let us introduce a vector component I cap along this OX and along OY j cap. Similarly, along OZ I am going to introduce k. I have introduced three vector components along OX I cap, along OY j cap and along OZ k cap. By using this graph, I am going to derive the formula for gradient. See, there is something called del operator that is given by the reverse triangle del operator. In other words, we will call that as a vector differential operator. The basic definition of this operator is given by dou by dou x into I cap, which is with respect to x, plus dou by dou y into j cap, this is with respect to y, and as well as dou by dou z with respect to k. The basic definition of del is given by dou by dou x I cap plus dou by dou y j cap plus dou by dou z into k cap. Now we need a function. What kind of function we need? A scalar point function with respect to three variables. Since we have three-dimensional graph, so we will introduce a function with respect to three variables. Let us call that function as phi. Phi is a function with respect to three variables x, y, z. Right? Now we usually denote gradient as del phi. Let us multiply this del and phi together and we'll check what happens. See here, when you multiply this del and phi together, del phi is equal to what is del? This is dou by dou x I cap plus dou by dou y j cap plus dou by dou z into k cap. This vector differential operator should be multiplied with this scalar point function phi. I think you all know dot product. It is very simple. See here. So del phi is equal to, let us bring this phi inside bracket. So dou by dou x of phi becomes dou phi by dou x along I cap. Similarly, dou phi by dou y into j cap plus dou phi by dou z into k cap. And this is what exactly the formula to find out gradient of the given scalar point function. I hope you understood this. See, again, let us name all the things in the formula. This is nothing but an vector differential operator, and phi is what? The scalar point function with respect to three independent variables x, y, and z. Dou phi by dou x is what? It is the partial derivative. Dou phi by dou y is also partial derivative. See, dou phi by dou x is nothing but partial derivative of phi with respect to x. Dou phi by dou y is nothing but partial derivative of phi with respect to y. And in last term, dou phi by dou z is nothing but partial derivative of phi with respect to z. Okay, let's move on to the first problem. Here, they are asking to find out the gradient of the scalar point function. The function is given by phi is equals to x cube plus y cube plus z cube minus 3 into x into y to z at given points 1, minus 1 and 2. So, after getting the result, we need to evaluate the given obtained result at the 3 points 1, minus 1 and 2. First of all, what is the formula? What is the given data? See here. Given phi is equals to x cube plus y cube plus z cube minus 3 into x into y. This is what the given function to us. We know that gradient of this scalar point function is given by this del phi It is the partial derivative of phi with respect to x. Similarly, what is dou phi by dou y? It is the partial derivative of phi with respect to y, and dou phi by dou z is nothing but partial derivative of phi with respect to z. So before doing the partial differentiation, make sure that while doing the differentiation for x, you should treat y and z as constant. Similarly, while doing the differentiation for y, you should treat x and z as constant. Apart from that variable, you should treat all the remaining variables as constant. By using that concept, let us do the partial differentiation. See, del phi is equals to, so this is dou by dou x of phi. Phi is what? The given function. Differentiate this entire function with respect to x by treating other variables as constant. Differentiation of x cube is what? 3x square plus we have y cube, but our differentiation is with respect to x, but we don't have x here. This is the constant, and differentiation of constant is 0. This becomes 0 plus again z cube. We don't have x term there. It becomes 0 minus. See, differentiation of constant is 0, but differentiation of constant in function is not 0. Please remember that. Let us write down all the constants first. 3, y, z are the constants there. Apart from this x, whatever we have, that becomes a constant. Remaining is what? X. Differentiation of x is 1. We need not write that along. Plus, what is dou phi by dou y? Differentiate the same function with respect to second variable, that is y. By using the same concept here. First term is what? X cube, but differentiation is with respect to y, that is the constant, it becomes 0. Plus, second term is what? Y cube. Differentiation of y cube is what? 3y square. Plus, differentiation of z cube is again 0. Minus, differentiation of 3 into x into y into z. We have a constant as well as a function at the same time. Let us write down the constants first. 3x, z are the constant, and differentiation of y is 1, and this is along j cap. Plus, see here we have dou phi by dou z. This is nothing but the partial derivative of phi with respect to z. Let us differentiate this whole function with respect to last variable, that is z. So what will happen? Since the first term is x cube, there is no z term, it becomes 0, and second term is what? Y cube, but differentiation is with respect to z, that becomes again 0. Plus we have z cube, so partial differentiation of z cube is what? It is 3z square minus we have 3 into x into yz. Let us write down the constants first. So 3xy are the constant, and differentiation of z is 1. We do not write, and hence partial differentiation is successfully completed. Let us write down this same equation as, see, simplify it. So it is 3x square minus 3 into y into z along I cap plus 3y square minus 3 into x into z along j cap plus 3z square minus 3xy into j cap. So partial differentiation is completed. Now just go back to the question and see that points are all given or not. See, here they have given 3 points, 1, minus 1 and 2. Here the value of x is 1, the value of y is minus 1, and the value of z is plus 2. Let us substitute these 3 values in the result and check what will happen. See here, del phi at the 3 given points, 1, minus 1 and 2. It is very simple. Wherever you have x, replace it by 1. Replace y as minus 1 and replace z as plus 2. And it becomes 3 into 1 square minus 3 into value of y is minus 1 and z is plus 2. And please maintain the proper brackets while doing simplification. Plus 3 into y square means what? It is minus 1 square minus 3 into we have x into z. X is 1 and z is again 2. This is along j cap plus the last function is 3 into z square, that is 3 into 2 square minus 3 into x value is 1 and y value is minus 1. Now the final step of the problem is we just simplify it. So 3 into 1 square is 3 and this is plus 6 along I cap plus this is 3 minus 6 j cap plus 2 square 4 equal to 3 12 plus 3 with respect to k cap, and hence the last step is what? This is 9 radius of the given scalar point solution at the given 3 points, that is 1, -1 and 2.